Hey, hi, good afternoon, everyone. So, today's video we are going to discuss about a topic which is very, I mean, most of you are familiar with the concept that's called the big data. Yes, so in the big data concept, if you are into data engineering and you want to understand being a data engineer or being a big data engineer, if you're working with Hadoop or Spark, with PySpark, and you want to get into a GCP environment, or you want to know what exactly the tool, what are the services available in big data in Google Cloud Platform for the big data. So that topic we are going to discuss on Google Cloud Platform. So with the agenda for today's session, this is the agenda for today's topic. We'll talk about the service called the big data, and that we have a two framework that is called Hadoop and Spark. And in that, the service name which Google Cloud provide, that is called Dataproc service. Yes. So if you are working on AWS, that service, and you want to implement big data, Hadoop, Spark, so the service name is called EMR. If you're talking about Azure, that is called HD Insight, where you will get the framework big data technology, Hadoop, Spark. Similar, we have a Google Cloud, and the service name is called Dataproc. In this environment, you will get your Hadoop and Spark framework. Okay, with all the options you have a MapReduce, you have a Hive, you have a HBase, that Hadoop ecosystem we'll talk about. So before coming to the part to the Dataproc service, it's equally important to understand the big data. Those who are new and those who are beginner into the big data, let's talk about the big data concept first, and what are the major challenges we are facing in the big data. That's more important. And being into learner, if you are looking for some big data technology, what are the major technology we have today? So we'll talk about the big data framework in terms of Hadoop and Spark. Okay, so coming to the big data part, if you talk about the worldwide data is galloping day by day. Okay, and data like you have a social media, you have app. This is nothing, it's all the platform where we are feeding the data. The customers are feeding the data, and they are doing multiple analysis, and they're using for the for different purpose, in case of business decision or some kind of analysis, customer understanding, to improve the services. That depends completely on the business nature. So coming to know the part of what exactly the big data and what are the platforms. So let me show you something today. Before coming to the Google Cloud, it is more important to understand the platform, and the platform, like you see that a real time, some kind of insight I'm showing it to you, that is called social media. Right, you are on Facebook, you are on Twitter, LinkedIn, you are on Instagram, yep, you have a YouTube channel. So mainly this, all the platform, it's nothing, it's all the big data application. Okay, mainly we are working with the data, more and more data, the customers worldwide feeding the data, and this data we understand what they're doing this data at the back end. So we will understand, and what kind of framework, what kind of softwares they are dealing with the structured, unstructured, variety, volume, that is called the 3V, volume, variety, and velocity. And this 3V is called what? Big data. The complexity of this 3V is that it cannot be that it cannot be handled on a normal database. Like we have a traditional database, you might be working with a MySQL, you might be working on a SQL server. But do you think so that a data which large volume, like if you see that Facebook, if I ask you, what is the volume of the Facebook, right? If I say that per second, right, what is the traffic we have, the velocity, in terms of velocity, right? So new users, we have a different category, mobile users, messages, and different activity what we are doing, we have categorized here, and this is worldwide per second clicks. This is technically called click stream. This is all the platform where we are doing the clicking, and we are feeding the data, we are moving with the data, right? So what is the bandwidth of this data, right? Terabyte of data per minute, huge data. So this is a quick insight of all the social media. We have Facebook, Twitter, we have X, that is what, YouTube, Tumblr, right? A great understanding, a better understanding to get the idea of all this platform, how it works. Okay, so the questions come then if this is the scalability, this is the bandwidth, this is the velocity, the data and the volume, it's more important, it's more unstructured, organized data, because social media, you're not making some kind of index schema, right? You're simply dumping the data. So how to deal with this unstructured data? In terms of big data, 80% data are what? unstructured. So how are you going to deal with this data? Because your RDBMS is completely into structured organized way. Work on schema. Even a single small changes in the schema, if it not match, you will get a syntax error. And it's 110% work on a structured data, rich data. So of course, and it has some kind of, it can maintain a limited volume of data in terms of batch processing, in terms of real time. Now, what is the questions come here, that if I'm asking, your client is giving you 10 TB data and asking you to process this data in a couple of hours, and you're working with a traditional database. In that case, what you're going to do, what you're supposed to do. So of course, the traditional database or the traditional infrastructure what you are having, it won't help you to deal with this volume of data. Not only the data, right? The data with complexity, not only the volume, you have 10 TB, this volume 10 TB, out of 10 TB, an average 6 to 8 TB data are unstructured. So you have to do the data mining, data cleaning too much to make the data rich, right? To make the data organized, semi-structured, and then you are dumping the data onto your traditional database. It is time-taking process. But the client is expecting the result in a couple of hours to take some, that business decision. So in that case, you won't be in the position to commit your customer. So in that case, what are the scenario, what are the options you have? So definitely the data you are dealing with, that the data what you are getting from the client end, this is not a normal data. It's what volume, a variety, and very important, the velocity. You can see that per second, what is the velocity, the number of clicks per second. This is the velocity of data. So ultimately this is 3V, volume, variety, and velocity. This is how we deal with, how we define the big data. And if you talk about the big data, if you're dealing with the big data, please do not go and approach, it will not approach with the traditional database. It won't be the solution for you. You will be, ultimately you will be in the trouble. You maybe lose the client or business. Okay, so your approach should be very much clear. So you have to find out a big data technology. So in terms of big data technology, what options we have? So we discuss about, if you ask me what Facebook, what YouTube using, of course they are not using a traditional. They are having a large volume data with high scalability, and of course they are going to work with the technology which handles the big data. So if you ask me what are the big data technology we have, so we have a two traditional and well-known technology. One of the emerging demanding technology, one is a Hadoop, which is very popular since started in 2011-12, Hadoop. Okay, and the second is what called the Spark. There are certain limitation we have in this framework, so we will understand the certain limitation of this technology and where to use Hadoop, where to use the Spark. In that certain things we will talk about, and with that we will discuss some about ecosystem of this framework. Okay, so coming to the part of the big data, right? So we understand the big data. Let's talk about the technology what we have, Hadoop and Spark, right? So here we have, okay, so the customer is more focused on time and money, right? The business model nowadays is what it's calling volume to value. The more data you have, the more business you can, we all see, right? When you download the app, they insist you to share your data. Without that, you're not allowed to use your application, any app. Okay, because the business models say that the data which you're getting from the customer, you are doing certain analysis, you understand the customer behavior, based on that you are approaching to the customer to give the best service and dynamic pricing. So how this all possible, how at the back end what set of team they have, and the more important thing, what advanced technology they are using. Okay, so mainly if we talk about technology wise, we have today a business of volume to value, where we have to give the big data solution to our customer, to the client. Okay, so earlier you have 100 TB data on RDBMS, a traditional database where you're processing. It takes a month, or it may take a couple of weeks. All right, but as per the client expectation, waiting for the result in a couple of hours. So finally you find out some solution. So what are the big data solutions we have? We have a technology like Hadoop, Spark, NoSQL, right? And finally we decided to migrate your data from your traditional on-premise to cloud, to the big data platform like Hadoop and Spark. These are the software. Where to deploy that, the second part will come where this softwares we are going to deploy, that is how the cloud is come the picture. But let's focus now about the framework, the softwares Hadoop and Spark. So we are migrating data from RDBMS. This is how the industry working. They are migrating data from your traditional database to Hadoop database, right? Hadoop having a database name is called HDFS, Hadoop Distributed File System, where they store the data in a file system format. Okay, so data migration is equally important. How you migrate data from RDBMS to Hadoop? You need an ETL tool. Okay, ETL, you might be heard about Informatica, Data Stage. These are the traditional ETL tool, but this is the license. So Hadoop, I talk about Hadoop ecosystem. So in Hadoop ecosystem, we have a tool called Scoop. It's a Hadoop ETL tool, right? So you don't need to bother about any other ETL tool, third-party tool. In Hadoop ecosystem, you have a tool that is called Scoop, which can help you to migrate data from RDBMS to Hadoop. It's specially designed for the structured data and offline. So Scoop is nothing, it's a SQL plus Hadoop concept. Okay, so it's one of the ETL, it's one of the massive, we are using ETL in Hadoop ecosystem, and through that ecosystem of, through this help of Scoop, we are migrating data from RDBMS to Hadoop, where on Hadoop database means your HDFS, Hadoop Distributed File System. Now, once the data comes stored in the file system, it can store the data any kind of format. You have a structured audio, video, images, logs, text, anything, any format you have, structured, unstructured, semi-structured. It's good to just digest all the data. It's simply store the data in a like a local file system, like you store the data on your laptop. It's LFS, local file system. Similarly, it is being what is called HDFS, Hadoop Distributed File System. It has been derived from Google File System, Google database. Okay, so now coming to the part, okay. Right, so big data technology, as I told you that we have a database that is called HDFS, right? Yes, it's a distributed file system. It's mainly designed for big data, and it's being known for horizontal scalability. Horizontal scalability means you can increase the scalability, means if you have a machine, for example, just understand you have a laptop, you have a 8 GB of RAM, okay, and later you need to increase your RAM, so you can go and get additional RAM and you can add it a 4 GB RAM. So its total size of your machine is what, 12 GB RAM. But in future, if you needed some more RAM to add, remember that your machine have a limitation to add. You cannot add, you maximum, every machine have a limitation, 10 GB, 12 GB, 14 GB, 15 GB, and after that there is no such slot available, or your CPU does not support to that massive RAM in your machine. So that technically it is called vertical scalability. Vertical scalability means you have increased your machine RAM configuration from 8 GB to 12 GB. That is what you have increased the scalability of your machine RAM memory. But there are certain limitation, you cannot go more than 12 GB. So technically it is what this scalability is called, vertical scalability, which has a certain limitation. But there's another is called horizontal scalability. So horizontal scalability approach is very simple. You have a one RAM machine, all right, you get 8 GB of RAM, all right, later if you need the more GB, so I will get a one more machine of similar configuration, and now we will make a one, we will put in the same network, right. This is called Hadoop network topology, and now the two machine, that is technically called cluster, right. You might be heard about cluster, group of machine. So I have a cluster of two machine with RAM 16 GB. If you need in future some more, so you can keep adding the node, you can keep adding, the machine is nothing, it's called node. So you can keep adding the node in the cluster, and you can increase the scalability. So this is technically called horizontal scalability. It's a massive, and the worldwide people look forward for the only horizontal scalability, all the platform which you have, because its data is dynamic, it's coming every day. That's not being a limitation. The more data, the more business. The business model itself is called volume to value. So how they're going to define, they are focusing more to how to get more customer, how to get more data of the customer, and we can track, we can approach for to sell our products. The market strategies say that the data is all about the business. So one thing is very clear, if the data is the fuel for my business, we need a technology to drive this business. So no doubt this technology will give you a better platform to deal with such massive platform, massive data to deal with that. Okay, so now Coming to the Hadoop, so as we talk about Hadoop having a database that is called HDFS, and then we have a framework that is called MapReduce. It is equally a platform where you can run distributed application. So it's simple. You store the data and then you process the data. It's simple here as well. You store the data on HDFS and you need a platform to process the data. All right, we have a MapReduce framework which helps to run a distributed application. Right, and we have a multiple version of Hadoop 1.x, 2.x, 3.x. So in 3.x or 2.x, you see that MapReduce has been replaced by Yarn, yet another resource negotiator. Okay, it's another massive platform to deal with the distributed application. All right. So now, if you ask me what being the tradition, what exactly the industry working right now? So yes, you have a Yarn. MapReduce is completely obsolete. So Yarn is the right now the platform where we deal with, and because of the Yarn only, we are getting support from the Spark. Later we will talk about the Spark also. So this is the two you can say the component of Hadoop. The two component of Hadoop, one is HDFS which store the data, and the Yarn is what nothing here, a platform where we have we run a distributed application. Okay, so now what we have. Okay, so if we talk about Spark now, what exactly Spark? Why we need the Spark if we have Hadoop? The question comes here, right? If we have already Hadoop, then why we need the Spark? Now understand the limitation of Hadoop, where Hadoop cannot, what Hadoop cannot do. That is equally important to understand, right? So let me go back. So I show you the streaming, right? So let's say this is one insight. I'm showing it to you, right? Okay, so you ask me, hey, can you help me to know, right? You see that real time. Real time means I want to know the traffic of my website per second. Per second, how many users are visiting, or the traffic I want to know. So 50, 60 users, 29 mobiles, messages, you can see all that. That's per second. So, and technically, it is what called in real time. Okay, it's a real time. So per second or near real time. 5 second, 20 second, the results you are getting. That's technically called near real time. Like when you call to Ola, Uber, it takes 10 to 15 seconds to confirm your cab or food you order. So that's near real time processing is going on. So ultimately, they have to take the request online, and the applications are similar. That's not different. Right. The questions come here. If we have such business model when we have to respond to a customer in real time or near real time, so then, and ultimately, what technology of big data technology with support in real time or near real time? Does it Hadoop? No. So Hadoop does not support near real or real time. It is good only for batch processing. Now you might be thinking, what is batch processing? Or if you're familiar, OLAP, online analytical processing, right? So Hadoop is good for, Hadoop is fit for batch processing only. I mean, let's take an example. So if I say, what is batch processing? Batch processing means to process a data in bulk. Very simple. To process data in a bulk format. Like, so if I ask you, hey, can you give me the result per hour, right? What is the traffic of my website per hour? So bulk job per hour. The time frame matter. Real time and batch. Okay, per hour, it can be per day, it can be per week, it can be per month, it can be per year. Depends upon your business requirement. So Hadoop can help you to process such data in batch, at a regular interval and long interval, and you can deal with the big data, no doubt. But if you say Hadoop, hey, can you help me out to give me the result in real time or near real time? Hadoop say, no, sorry. Don't expect me such job. I'm good for a bad job, not for near real time or time job. Okay. Then questions come. Now, mainly the projects, most of the application you see nowadays that it's a combination. You have to do OLAP, you have to do the OLTP, both jobs. You cannot say that to the client, no, I'm restricted to use OLAP job only. We don't have such features, the technology what we are using. Right? It sounds good. So you have to give the solution. Right, and you have to come with a solution. There's no any other options. So finally we come with the technology that is known as Spark. Yes, the reason why is Sparks. So Spark is what in-memory process. Hadoop is a disk processing. It processes data in a disk. It supports the commodity hardware, low configuration machine also. You can take a 2 GB of RAM laptop and I can help you to set Hadoop. That is possible, but it will be slow, but it can be manageable. But if you say that, hey, can I run Hadoop or Spark on 2 GB machine? No, not possible. Spark is an in-memory process. It needs a good memory configuration, CPU, for the better performance. Okay, so that's what the difference. You have to understand the Spark is good equally for different type of job, batch job, right? In-memory process or real time, right? Hadoop is good for batch and it's a disk process. Although that Spark say in-memory process, when you talk about in-memory means configuration. It does not support low configuration, means it does not support commodity hardware. You have to get a good configuration, at least 8 GB of RAM. Okay, so you will get the better response and faster response in there. So that is how the Spark comes on the picture. Spark is written in Scala, but also you have two more programming language you can use it, Java and Python. Now if you say what mainly we use industry and what mainly used on Spark, so Spark, that's called PySpark, Python with Spark. It's all the rich library repository are available enterprise level in Python. So PySpark is the top-notch demand. Scala is also, but yeah. All right. So this is all about your. Right. Let's talk about the ecosystem. Hope you get the idea about the difference between Hadoop and Spark. Right. Where to use Hadoop, where to use Spark. Mainly, now you say that Hadoop now become a database. All right, where the data gets stored. Spark does not have its database, so the Spark dependency, it needs a database, and Hadoop is fulfill the requirement, and from there it take the data and it load it in memory, that is in memory process, and give the output. So what Hadoop have the loophole, Spark give the solution. What Spark have the loophole, Hadoop give the solution. This is what the dependency, and mostly I found enterprise or industry, when you talk about the client, the majority are working with the big data technology called Hadoop and Spark. Mostly I feel that there are a number of technology which work with the big data, but major I find they have the Hadoop and Spark to deal with the big data technology, and Hadoop and Spark is mandatory. If you learn only Spark and you are completely new, it's a half knowledge for you. If you know Hadoop and you're not working with the Spark, it's a half knowledge. A knowledge will only give you the clarity for the big data to deal with the multiple use cases when you have a knowledge of Hadoop and Spark. So work on to both sides. Okay. Coming to the Hadoop ecosystem, we have HDFS. As I told you that we have a component. So Hadoop component is HDFS and YARN, we have discussed before. And if you talk about the ecosystem, right? Ecosystem means you can integrate. If certain limitation you have into the component, then in that case you can do what? Integrate. Okay, that ecosystem we have. So in terms of database, we have a database called HBase. It's the external database of Hadoop. All right. So HDFS has certain limitation, and HBase give the solution for that. But you have to integrate this tool with your Hadoop. That's how it comes under the ecosystem. And in terms of data processing, yeah. So we have a Hive, one of the major tool that for data processing on Hadoop we use. It's called Hive. It's a data warehouse and specially designed to people those who are from RDBMS background. So if you say that I'm from the RDBMS background and I want to get into the big data technology, what tool I should use? What should I learn it more? So I will suggest you learn it. Hadoop is important, but in ecosystem you focus more on to Hive because it's similar to SQL. That is called SQL of Hadoop. Right. So we use HQL, Hive query language. It's similar like the way you are using, creating the table, define the schema, loading the data, insert, delete. Right, the CURD operation. Right, yes, the CURD operation update. There's certain limitation also you have to look onto this part. Okay. All right, Pig is also one option, but as I told that if you ask me what frequently we use, So we have Hive. Okay, and then what other we have, that is called the Spark. Right, MapReduce options we have. People those are from the Java background, they can use the MapReduce, but again it's not frequently being used, getting obsolete. All right, so market in Hadoop trending on HDFS, HBase and Hive. So these are the three tools first we have to focus, and then you jump onto the Spark and learn Spark, Spark SQL, Spark streaming, Spark ML if you're being into the data scientist. So these are the tools. What is the combination we have seen into the market, into the industry, the combination of Hadoop and Hadoop ecosystem, Spark and Spark ecosystem, where they club together and getting the better results. Okay, so in the further session we will talk about Spark and its ecosystem, and then we'll look onto that. We will design a cluster on our Google Cloud platform. Hey, don't forget to download our app for access to free courses and interactive quizzes. Stay connected with us on social media for updates and free content. See you next time. Happy learning.